When the interstellar object 3IATLAS transited our solar system, it bypassed standard classification and became a strict stress test for the laws of physics. The telemetry from this transit is not theoretical. Every measurement is sourced directly from peer-reviewed papers signed by researchers at peak institutions, including the Jet Propulsion Laboratory. Multiple independent teams, including scientists from the Goddard Space Flight Center, analyzed the exact same raw data. Despite looking at the identical numbers, they cannot agree on a single physical model for what this object actually is. The core of the discrepancy centers on a specific chemical measurement. Hydrogen is a single proton and a single electron. Add one neutron, and you get an isotope called deuterium. Cosmologists use the ratio of deuterium to ordinary hydrogen, the DH ratio, as the standard metric to date the formation of celestial bodies. Deuterium also has a highly specific application. When paired with a second isotope called curium, deuterium becomes the primary ignition source for fusion energy. It is the exact reaction that human physics uses to detonate hydrogen bombs and power our experimental fusion reactors. To understand the 3IATLAS data, we need the universal baseline. In standard, heavily studied comets like 67P, the ratio is exceptionally low. You will typically find one deuterium atom for every 5 to 10,000 hydrogen atoms. To measure 3IATLAS, astronomers used the James Webb Space Telescope, leveraging its unparalleled spectroscopic instruments to analyze the water vapor shedding off the object. This chart displays the first set of published measurements. Compared to the tiny baseline of Comet 67P, the water vapor of 3IATLAS carried a DH ratio of 1 in 100. That breaks the established cometary baseline by a full order of magnitude. Adding the second paper's methane data to this chart shows an even more severe deviation. In the methane shed by 3IATLAS, the deuterium ratio is 3.31%. That concentration is roughly 300 times higher than the methane DH ratio found in our solar system's massive gas giants. 3IATLAS is the most deuterium-enriched object ever observed in the history of astronomy. It is transiting our solar system carrying extreme, highly concentrated volumes of primary fusion fuel. The standard astrophysical literature offers a strict natural explanation for this chemistry. Researchers propose the extreme enrichment is the result of isotopic fractionation, a chemical process occurring in the outer disk of an ancient primordial star system. The mathematics of isotopic fractionation demand a highly specific environment. To naturally achieve a 3.31% DH ratio, the environment where the object formed must be extraordinarily cold, dropping below 30 degrees Kelvin. Avi Loeb, former chair of Harvard's astronomy department and founder of the Galileo Project, identified a fatal flaw in this model. His objection relies entirely on a hard, unyielding constraint of cosmology. This graph plots the temperature of the cosmic microwave background against the age of the universe. It tracks the residual heat left over from the Big Bang, which filled the early cosmos with intense ambient radiation that has slowly cooled as the universe expands. The natural explanation requires 3IATLAS to have formed 10 to 12 billion years ago. On the graph, that epoch corresponds to a cosmological redshift of 10. At redshift 10, the ambient temperature of the entire universe was approximately 30 degrees Kelvin. The laws of thermodynamics are absolute. An object cannot passively cool below the temperature of the radiation environment surrounding it. The natural model requires a formation environment colder than 30 Kelvin. The universe itself, at the time the object supposedly formed, was exactly 30 Kelvin. The proposed natural origin requires physical conditions that the cosmos prohibited. The chemical composition is only the first discrepancy. Tracking the orbital kinematics of 3IATLAS reveals a distinct failure in standard cometary physics. Active comets experience non-gravitational acceleration. Solar radiation sublimates the ice. This outgassing creates a physical reaction force, pushing the comet in the opposite direction. This vector schematic illustrates the accepted mechanics. Astrophysicists model these sublimation forces routinely. The outgassing creates a highly predictable opposite thrust vector, allowing researchers to plot cometary trajectories with precision. When applied to 3IATLAS, the non-gravitational acceleration data completely deviates from the standard model. No mathematical variation of the object's assumed shape, rotation, or composition can produce the observed thrust vector. The acceleration points in an inverted, mathematically prohibited direction. 3IATLAS is accelerating along a physical path that its own surface sublimation cannot generate. Something else is generating the thrust. Natural comets are chaotic agglomerations of ice and rock. Volatile materials are distributed randomly across their internal volumes and surfaces. Because the surface geometry is random, the resulting outgassing jets are inherently chaotic and asymmetric, exerting irregular rotational forces as different volatile pockets catch the sun's heat. To study the outgassing behavior of 3IATLAS, researchers utilized the optics of the Hubble Space Telescope. Hubble's data confirmed that 3IATLAS was not ejecting a chaotic spray of sublimating material. Instead, it was venting through exactly 3 distinct jets. The arrangement of those emissions defies natural accumulation. The 3 jets were structured in perfect geometric symmetry, a configuration that completely lacks precedent in the entire catalog of observed comets. Perfect geometric outgassing implies a highly structured internal architecture, dictating exactly where and how material is released. It directly violates the random accumulation model of celestial bodies. Astronomers plot the brightness of a moving object using a light curve. A standard, tumbling, irregular rock produces a messy, unrefined fluctuation in brightness as different faces catch the light. The luminosity data for 3IATS is exact. It pulses with a perfectly consistent brightness variation that repeats every 16 hours and 10 minutes. That degree of angular stability points entirely away from random tumbling. It indicates a repeating, cyclic process operating on a rigid schedule. The final physical discrepancy lies in the object's coma, the envelope of gas surrounding the nucleus. Spectrographs analyzing this gas cloud detected vaporized iron and nickel at extreme abundance ratios. Passive solar heating sublimates ice into vapor. But turning solid structural metals like iron and nickel into a gaseous state requires immense concentrated thermal energy. A clock-like pulsation sequence combined with the ejection of vaporized structural metals strongly indicates an active, energetic internal mechanism. It does not describe a passive rock warmed by the sun. The physical data forces an examination of the official timeline. According to the public record, 3I/Atlas was officially discovered and logged in July 2025. A query of NASA's archives later revealed a contradiction. The Transiting Exoplanet Survey Satellite, or TESS, actually captured 3I/Atlas in its imaging data in May 2025, 2 full months earlier. TESS operates a dedicated alert stream specifically designed to flag moving solar system bodies. Yet this highly anomalous, hyperbolic intruder moved through the data stream and was silently archived without triggering a single public alert. In response to the growing list of anomalies, a researcher submitted a Freedom of Information Act request to the Central Intelligence Agency regarding 3I/Atlas. The agency issued a GLOMAR response. They could neither confirm nor deny the existence of records. In intelligence law, this specific formulation is invoked exclusively when the mere act of acknowledging a record exists would compromise classified intelligence. Applying a classified intelligence block to an astronomical observation confirms a reality separate from the academic debate. Institutional intelligence agencies are treating 3I/Atlas outside the bounds of standard scientific phenomena. This matrix table lists the object's behaviors. Despite cataloging 22 separate anomalies, from inverted vector thrust and geometric jet symmetry to periodic pulsing and vaporized metal, not a single peer-reviewed paper has proposed a unified natural model capable of explaining all of them simultaneously. Which brings us back to Harvard's Avi Loeb. At the conclusion of his thermodynamic analysis, he published a single precise question. He asked, since deuterium is fusion fuel, might its overabundance in 3I/Atlas flag a technological signature? Currently, NASA and global space agencies are executing a coordinated, rapid push to format and archive every byte of telemetry captured by the James Webb, the Hubble telescope, and MAVEN missions. The rush is dictated by orbital mechanics. 3I/Atlas is accelerating on an exit trajectory out of our solar system. It will never return, and humanity possesses no propulsion technology capable of catching it. 3I/Atlas forces a permanent choice. We either quietly accept a natural model that openly violates the laws of thermodynamics, or we rigorously investigate the presence of an artificial interstellar object, relying entirely on an archive of data that is now sealed forever.